Astronomy is the science of celestial bodies that helps us explore the universe, its structure, and evolution. However, one of the most challenging tasks astronomers face is measuring distances to objects in space. Whether they are nearby stars or distant galaxies, accurate distance data are important for understanding the structure of our universe and its dynamics. In this text, we will look at what methods are used to measure distances to galaxies and how they help us study the universe. Understanding the concept of distance in astronomy. Before delving into the methods, it is worth understanding what we mean by distance in the context of astronomy. Unlike terrestrial measurements, where distances are expressed in meters or kilometers, astronomy commonly uses light years, parsecs, and megaparsecs. A light year is the distance light travels in 1 year, approximately 9.46 trillion kilometers. A parsec is equal to about 3.26 light years. These units of measurement make it easier for astronomers to work with the vast distances in space. Measurement problem. Measuring distances in space is far from an easy task. The reason for this is that many cosmic objects, such as galaxies, are at such distances that traditional measurement methods that work on Earth cannot be applied. As a consequence, astronomers use a range of specialized methods to measure distances to stars and galaxies. Methods for measuring distances to galaxies. Parallax method. The parallax method is one of the oldest and simplest ways of measuring distances. It is based on observing the change in the position of an object on the celestial sphere if we change the point of observation. This method is effective for measurements at relatively small distances, such as for the nearest stars. However, for more distant objects, such as galaxies, parallax becomes insufficient because its effect is too small. Therefore, parallax is mainly used for measurements within our galaxy, the Milky Way. Why is parallax insufficient for measuring distances to galaxies? Cepheids. Cepheids are variable stars that change their brightness regularly. Importantly, there is a clear relationship between their period of brightness change and their absolute brightness luminosity. This fact allows astronomers to use the Cepheids as luminosity standards to determine distances. If we know the period at which the brightness of a star changes, we can accurately calculate its luminosity, and then, knowing the apparent brightness, calculate the distance. This method has been widely used to measure distances to galaxies as far away as 100 million light-years. For example, it has been used to measure the distance to the Andromeda Galaxy. Why do you think stars with variable brightness, such as the Cepheids, are useful to astronomers? Type A supernovae. Type A supernovae are explosions that occur in double star systems when a white dwarf, accumulating matter from its companion, reaches a critical mass and initiates a thermonuclear reaction. These explosions have nearly the same maximum luminosity, making them excellent candidates for determining distances. Just as with the Cepheids, knowing the apparent brightness of a supernova can be used to calculate its distance. Type A supernovae are considered an important method for measuring distances to the most distant galaxies at distances of billions of light-years or more. They play a key role in our current understanding of the expansion of the universe, as the detection of supernovae at different points in space has helped to establish that the universe is expanding at an accelerating rate. What conclusions can be drawn from the study of Type Ia supernovae for our model of an expanding universe? Redshift. Redshift is a phenomenon in which light from distant objects in space is shifted to longer wavelengths, that is, the red spectrum. This effect is related to the expansion of the universe. The farther away an object is, the more its light is shifted toward the red. By studying redshift, astronomers can not only determine the speed of distant objects, but also the approximate distance to them. The redshift method is particularly useful for studying very distant galaxies, such as galaxies in the far reaches of the visible universe. This discovery was one of the most important pieces of evidence that the universe is not just existing, but expanding. How does the redshift change as a function of the distance to an object, and what does this tell us about the universe? The thin line method. The thin lines method is used to determine the distances to galaxies when scientists examine the spectra of light that passes through a galaxy. Each molecule and atom has its own unique spectral fingerprint. Using this method, astronomers can accurately estimate the galaxy's removal rate and therefore its distance. This method not only helps to measure distance, but also to study the chemical composition of galaxies. What molecules and atoms are most often used by astronomers to determine the spectrum of galaxies? Modern technology and the future of measurement. With advances in technology, astronomy has gained new tools and methods for exploring the far reaches of space. Modern telescopes, such as the Hubble Space Telescope, help capture incredibly clear images of distant galaxies. In the future, our ability to measure the distances to galaxies is expected to improve even further with the development of new telescopes, such as the James Webb Space Telescope. In addition, concepts such as using gravitational waves to explore the cosmos also promise to radically change the way we measure and explore the universe. What new technologies do you think can help astronomers more accurately measure distances to the most distant objects in space? Measuring distances to galaxies is not just a technical challenge. It is key to understanding our universe and its evolution. Each method we consider provides a unique view of the cosmos, and each has its own limitations and capabilities. However, thanks to these methods, we have been able to learn more about the universe than we could have imagined a few decades ago. With each step forward in astronomy, we are breaking new ground and getting closer to unraveling the most fundamental questions, from how the universe works to how it will evolve in the future. If you are interested in continuing to explore the mysteries of the universe and learn new amazing facts about the cosmos, subscribe to our channel. We regularly publish exciting content that will help you delve deeper into the world of astronomy and beyond. Don't miss new videos, stories, and explorations that will open new horizons for you. Subscribe and stay up to date with the most interesting discoveries.